In this unit, we've looked at how to find slope 3 different ways. We've looked at how to find it given a graph, given a table, and given an equation. Now we're going to learn how to find slope using a formula. So up to this point, every time we've talked about slope, you need to understand that slope is the vertical change over the horizontal change. So when we look at it on a graph, we're looking at the changes in y over the changes in x, which again is represented by this formula here, the change in y, or delta y over delta x. So again, today we're going to learn how to use it from an equation. So let's look at how to find slope from an equation. So anytime I'm given 2 coordinate points, I can find slope using the formula y2 minus y1 over x2 minus x1, because again, this is representing the change in y over the change in x. Now, notice here, this is the way we're going to label these points. The first point will be labeled x1, y1, and the second point will be labeled x2, y2. So let's look at a few examples so you kind of get the idea. So if I'm given 2 points, like 7, 5, and 10, negative 1, I can label them x1, y1, x2, y2, and use them in this equation to find out the slope. So let's do that. So again, we know that in every coordinate we have an x and a y, so I'm going to label that to start with. So it really doesn't matter, but we'll just label this one x1 and y1 since it's the first one, and then this second one will be x2 and y2. So let's take these numbers out and plug them in the formula. So we're going to always start with our y's first, and we're going to start with the second one. So I'm going to take the second one and subtract it from the first one. So we have negative 1 minus a positive 5. So that's y2 minus y1. And then we're going to look at our x's, and again we're going to take the second one and subtract it from the first one. So that's 10 minus 7. So this is what our numbers look like plugged into our equation. So we have negative 1 minus 5, which gives us a negative 6, and then 10 minus 7 would give us a positive 3. So therefore, when I'm finding the slope, I have negative 6 over 3, which will reduce to a negative 2. So therefore, in this equation, the slope would be negative 2. Now really, let me explain why this works. If I have my table here of my x and y values, and I look at my x compared to my y, I can always look at the points in the table. So I have 7 and 5 and 10 and negative 1. So remember, slope, we just look at our changes in y over our changes in x. So to go from 5 to a negative 1, that's like saying minus 6. And from 7 to 10, we're adding 3. So again, if I'm looking at the change in y over the change in x, I have a negative 6 over a positive 3, which is exactly what I got here. And that's really why it works again. All right, let's take a look at the second set of points. So this time we have 3, negative 2, and 3, 4. So again, I can label these. You should know they're always x and y, x and y. We'll go ahead and label this x1, y1, and the second point x2, y2. That way it matches with the table. Now understand, this still works if I were to plug it in on my table as my x's and my y's. I could plug in 3, negative 2, and 3, 4, and look at the change in y over the change in x. And I should see the same thing that I'm going to see by using the formula. So we're going to start with y2 minus y1. So we have here 4 minus, in this case, a negative 2 over the x's, which is 3 minus 3. So here, 4 minus a negative 2 is actually a positive 6, and 3 minus 3 is 0. So when I have 6 divided by 0, that just leaves me with a slope that is actually undefined. Okay, if you look at your calculator and you plug in 6 divided by 0, it doesn't work. You cannot divide anything by 0. You'll get an error sign. So when that happens, this slope is going to be undefined. It's actually not a slope. We've talked about those and what those lines look like before. And so therefore, you know you cannot divide by 0. All right, let's try this one. So again, we're given 2 points. We have in each of them an x and a y. I'll go ahead and label the first one x1, y1, and the second one x2 and y2. Remember, you can always plug them in a table of values and look at the same thing. So these would be my x's, these would be my y's. We have -2, 8, and then 8, 6. And again, you should see the change in y over the change in x is the same thing as what you get from the formula, because it's, again, the change in y over the change in x. So we're going to start with subtracting our y's. So here we have 6 minus 8. That's 6 minus 8. And then our x's. So here we have 8 minus a -2. So 6 minus 8 is actually -2. And 8 minus a -2 is actually a positive 10. So -2 over 10 is going to leave me with a slope. Here we can't divide it, or we're just going to reduce the fraction. The smaller number is on top, therefore we know it's going to be a fraction. So when I reduce 2 over 10, I'm left with -1 over 5. So the slope here would be -1 over 5. All right, so let's check this one out now. So again, we have 2 points. Still, every single time we label them x and y. We'll label the first one x1, y1, the second two x2 and y2. Remember, you can always look at it and plug it back in a table. It works the same either way. The formula is just a quicker way to do it. And when we're looking at the formula, again, we're still taking the y's over the x's. So I'm going to start with my y's first. So we have 9 minus 9 on top. And then my x's, I have 11 minus 7. So 9 minus 9 gives me 0. 11 minus 7 is going to give me 4. Here we have 0 divided by 4. And you can actually take 0 and divide it into 4. And that would give me a slope of 0. And again, look at your calculator and make sure that you know how you're plugging it in, that it's the top divided by the bottom. So again, we can divide 0 by a number, but you can't divide by 0. Have the 0 on bottom. So this would be the answer, slope of 0 for this graph. So when we're talking about an equation of the line, we really want it to be in slope-intercept form. And slope-to-intercept form is y equals mx plus b, or y equals b plus mx. Now, not every equation is going to be presented like that, as we've seen, and sometimes we have to solve for y. Now, again, not always are you going to even be given an equation. Sometimes you're just going to be given a point or a point and a slope. And if that's the case, we can use a different formula called Pointslope Formula to find the equation of the line in slope-intercept form. So what you're going to see here are 3 letters that mean a lot. We have slope, which is our m. You should know that by now. Slope is the m. And then we also have a point. We have x and y. And in this case, because we only have 1 point, it's x1 and y1. So those are the 3 things that go into this equation that we're going to change. The y1, the m, and the x1. So let me give you an example of how we would use this equation to find the slope-intercept form of an equation. So let's say you're given that the slope of the line is 2 and passes through the point 4, 6. Okay, so first of all, I know that slope is the m and this is 2. So I know that m is equal to 2. I also know that my point here is 4, 6. So I know that x is 4 and y is 6. So that means x1 is equal to 4 and then y1 is equal to 6. So what I'm going to do is I'm going to use that formula and replace it. So the formula was y minus y1 equals m times x minus x1. So I'm going to trade those numbers out. So I'm going to say y minus, instead of y1, I have 6 equals, instead of the m, I'm going to plug in a 2 times x minus, and instead of the x1, I'm going to put in a 4. So there's the numbers put into my equation. So let's go ahead and solve now. So you have parentheses, PEMDAS. This goes back to normal equation rules. We're going to start by getting rid of the parentheses and distributing the 2. So we have y minus 6 equals 2 times x is 2x, and 2 times -4 is a negative 8. I messed that up. A negative 8. So now we have this, or on the side of the y, which I have to solve for y, so I have to move everything away from the y, I have a negative 6. So in order to move that negative 6 to the other side, I would add it. And when I add it over here, I'm going to add it to the -8 because that's my whole number. So to finally end my equation, I'd be left with y equals, this cancels out. I have 2x right here, and then -8 plus 6 is going to give me a -2. So this would be the equation of the line in slope-intercept form given the slope and a point. Okay, let's try one more like this, and then we'll move on to a little bit more challenging. So again, in this one, slope of the line is 1/2, and it passes through the point -2, 3. So really the goal is to get it into this equation, and I'm going to use the point-slope formula to get there. So in this formula, I want 3 numbers. I have to find my m, my x1, and my y1. So the slope of the line is 1/2. That means that the m is 1/2. So I know m here is 1/2. I also know that it passes through the point -2, 3. So in every point we have an x and a y. So this is x1 and y1. So x1 is going to be -2 and y1 is going to be 3. So I'm going to use these numbers here to plug in to that equation. So let's use that equation. So we have y minus y1 equals m times x minus x1. So we're going to plug in for the y1, the m, and the x1. So let's do that now. So we're going to start with y minus, and in this case I'm going to change the y1 to a 3. I have equals, I'm going to change the m to a 1/2 times x minus, and I'm going to change the x1 to a -2. And I'm going to put that in parentheses just so I know it's a -2. So there's my numbers inserted into the equation. So first thing I'm actually going to do, because I have double parentheses here, let's get rid of this. A double negative is really just to add. So we have y minus 3 equals 1/2 times x plus 2. Again, because that's a double negative, and a double negative just means a positive. So we've got to get rid of these parentheses here, and we're going to get rid of it by distributing the 1/2. So when I distribute the 1/2, I'm going to be left with y minus 3 equals 1/2 x. I just put those two together. And then I take and multiply 1/2 times 2, and that gives me a positive 1. Now the final step is to move this 3 over by adding it. And when I add it over here, I'm going to add it to just the whole number, which is the 1. So my final point for this equation would be y equals, this 3's are going to cancel out. We have 1/2 x, and then I'm going to add 1 plus 3 and get a positive 4. So y equals 1/2 x plus 4 would be my equation for this line. Alright, so let's look at a second one that's a little bit different now. So this one just tells me that the line passes through the points 3, 5, and 4, 1. So I'm given 2 points. When you're given 2 points, you still have to find the slope by using the change in y over the change in x, this formula here. Now, you can do y2 minus y1 over x2 minus x1, or you can look at the points in the table and see the exact same thing. I'm going to use the formula. So again, I know that this is x and y, and this is x and y. This is going to be number 1, this is going to be number 2. So I'm going to start with the first y minus the second y minus the first y. So I have 1 minus 5 over my x's. I have here 4 minus 3. So 1 minus 5 is going to be a -4, and 4 minus 3 is just 1. So that means my slope, or as you need to know for the other equation, the m is going to be equal to -4 in this one. Now, I have given 2 points here, and it really doesn't matter which point I choose to use. So I'm going to go ahead and just use this first point, the 3, 5. So I know that in this point, I have an x and a y still. So we have x and y again, and we'll label this x1 and y1. So let's use my formula here. I know that in my formula, my m is going to be -4, my x1 is going to be 3, and my y1 is going to be 5. So I'm going to take these numbers and use them in this equation. All right, so let's use our equation now. So here, again, we have y minus y1 equals m times x minus x1. Okay, so I'm going to replace my numbers with what I know. So we have y minus, I'm going to change y1 to a 5, equals, I'm going to change my m to a -4. And then I have times x minus, and then x1 is being changed to a 3. Okay, so here's my equation with the numbers plugged in. So again, I'm going to start by distributing this -4. So we're going to then end up with y minus 5 equals -4 times x is just -4x, and then -4 times a -3 is a positive 12. That gets rid of the parentheses. So now I have to add this 5 to both sides to get rid of it, and when I add it over here, I'm just adding it to that 12. So we're going to be left with y equals, again this cancels out, -4x, and then 12 plus 5 is going to give us 17. So y equals -4x plus 17 would be my answer here. All right, let's look at one last one like this. So again, if I'm given 2 points, I can find the slope of the line using this formula here. And again, that's the exact same as if I were to plug it into a table and look at the change in y over the change in x. It all means the same thing. So this one here says the line passes through the points -3, -6, and -12, -6. So again, we know that we have x's and y's in both of these equations. This is going to be number 1. This is going to be number 2. So I'm going to start by taking y1 minus, or y2 minus y1. So we have -6 minus -6 in this case over my x's, which in this case I have -12 minus a -3. Okay, so really again, understand that this changes to a positive, so this becomes -6 plus 6, and this again changes to a positive, so this is -12 plus 3. So really I end up with -6 plus 6, which is 0, over -12 plus 3, which is going to be a -9. Doesn't really matter what the bottom is, because since the top is a 0, that means the slope, or the m in my line, is going to be 0. Now, it's still going to have an equation, and I still want you to be able to see that equation. So we're going to use our equation, our formula, in point-slope form. I'm going to use one of these equations. Doesn't matter which one. I'll go ahead and use the first one. Again, it doesn't matter. It's just whichever one you want to use. So I know here that my m is going to be 0, my x1 is going to be a -3, and my y1 is going to be a -6. So I'm going to take this to the next page and use my formula. Okay, so we again know our m is 0, our x1 is -3, and y1 is -6. So in that point slope form, y minus y1 equals m times x minus x1. We're going to start changing numbers. So we have here y minus, I'm going to change the y1 to a -6, equals, I'm going to change the m to a 0, times x minus, I'm going to change the x1 to a -3. Okay, there's a lot of negatives going on here, and I get that, and it'll be okay. So first of all, let's rewrite this, changing some of our double negatives. So we have y really plus 6 equals 0 times x plus 3. Okay, that'll make it a little bit simpler. Now, I'm still, same process, doesn't really matter, I'm still going to do the same thing. So we're going to start by distributing this 0. So let's distribute it as if it were normal. So we have y plus 6 equals 0x, and then 0 times 3 is really 0. So notice that it's canceling out the other side. Now, if I wanted to get rid of this 6, I would still have to subtract it. So I'm going to still subtract it from both sides, which then leaves me with the equation y equals, this cancels out, we have 0x, And then 0 minus 6 is going to give me a negative 6. Now here's the thing I want you to understand. 0 times x does not matter because anything times x or anything times 0 is 0. So what this equation becomes then is y equals negative 6. There's still a number there, there's still an equation, and it's just one number for the y because the slope is 0. There's no change in it. So the equation here would be y equals negative 6.